Okay, good morning, everyone. As usual, we start with questions from the homework. And as you realize, I'm starting to give you some review problems to help you for the final. So every day I will give you some integration problems, and I hope you guys will do them so you can remember the integration techniques. And if time allows, I will start giving you review problem from the first part of the course, the one about application of definite intervals, slowly to help you review for the final. And during this week, I will give you pop quizzes about integration. So I will not tell you, I will just tell you, just go ahead and take your pop quiz and to do mainly integration just to help you out to review this material. All right, now we go back to your questions. Do you have any questions about the homework? Please get started, put them on chat. Anybody? Okay. I know the problems were easy this time. It was mainly integration by parts and problem about ellipse. So if you have no questions for today, we're going to keep going with the ellipse. I will summarize in a few words what we did last time. So for the equation of the ellipse, so let us recall what's the equation of the ellipse. So we had the following. The equation of the ellipse is, that's the equation that you should totally basically memorize it. So that's the equation of the ellipse, x squared over x squared, and there is a plus in here, y squared over b squared. And we had two scenarios, and the scenarios are A larger than B and A less than B, okay? Now, in the scenario where A is the largest one, in this case, the foci basically are on the y-axis, and the ellipse is oval, of course, the shape of the ellipse, but it's stretched actually horizontally. So this is my ellipse, and the A represent the x-intercept. So this is my A from here to here. The B represent the y-intercept, that's the B. And in this case, the foci are right here. And the formula for the foci is c squared equal the largest value square minus b squared. And I mean, the foci have very nice properties that I will mention them when I finish talking about the ellipse today. For A bigger than B, and then it is elongated this vertically, so that's really the picture. The A is always, so I did not change, that's the A, that's the B, and the foci are right there, okay? So one more example, simple, before we move on. So one example is the following. Suppose I give you the following equation of the ellipse, just to write things up, equal to 4. And the question is, find, I want a lot of stuff. I want the vertices, I want the foci, and I want you to sketch, all right? Now, the first thing we do is what? When we have this equation, what do you think I should do? It doesn't quite look like the equation. We have immediately to put in the standard format. That's what I call the standard format. So to be able to interact with it, so step number 1, put it in standard format. It means I want in the format x squared over a squared plus y squared over b squared equal to 4. To be able to do that, so first we're going to divide by 4, and then go from there. If I divide by 4, this is going to give me over 4, will give me a 2. Divide by 4, and it's give me a 1. That's the standard format we're talking about. So what is the A and the B? This is the A squared. So this is usually, that's my A squared. And that's my B squared. So A, I just take the positive root. So A is square root of 2 and B is equal to 2. So immediately, what is bigger? Definitely B is larger than A. So when I'm gonna sketch this ellipse, so B is like this, so that's the 2, the A is definitely smaller. So I'm gonna sketch my ellipse, it's gonna look something like that. Okay, so that's always the B, which is a 2, and that's gonna be my A, which is the square root of 2. And in this case, the foci is on the y-axis. Right? Now find the vertices. The vertices, those are called the vertices, not those ones. The vertices are the point which lies where the foci are. So the vertices in this case, so vertices are 0, plus or minus 2 in this scenario. The foci, we just have to come up with the formula. C squared is the largest value minus the smallest. It means in my scenario is 4 minus 2, which is 2. So my foci would be 0 plus or minus the square root of 2. Okay, so that's to summarize what we did last time. Okay, today the first thing we're gonna see, and of course everything is in your lecture note, is a shifted ellipse. It means if you have an ellipse and you shift it. So what does it mean? So a regular ellipse, so that's my regular ellipse, the standard form, and I shift it so that the center will not be the origin. So that's what I mean by shifted ellipse. And the center is right here. So you take the ellipse and you shift it. So that's the center. And of course, the equation right now is not the other equation, but it's really, really fairly similar. So when you shift an ellipse, the equation will become x minus h squared over a squared. So instead of x, you will have x minus h plus y minus k squared over b squared equal to 1. So that's the equation of the ellipse where the center is h and k. And any questions? And everything is like before, in the sense that if a bigger than b, this is the shape of the ellipse. If b is bigger than a, it's going to be stretched, but it's going to be stretched horizontally. All right, so let us do 2 problems just to interact with this idea. So example number 1, I have one on my notes, probably I will copy it. So I'm going to take this ellipse, x minus 2 squared over 4. So I put in a standard format, y minus 3 over 9 equal to 1. Okay, so that's, when we see this, we should recognize that this is an ellipse. And the center here is very easy. That's the h, the center. So now the questions usually find the vertices, find the foci, and sketch. So I want the whole picture. So basically, how would you view this? So for me, this ellipse is the following. You start with the standard one. The standard one is the one centered at the origin. So I'm going to draw this one here. That's not really what I want, but just to give you an idea. It's this ellipse. What?
That? Where does that come from? To answer that, we have to go back to 2013, to Netflix's first ever show, House of Cards.
Can you please mute
What if I told you that you might have heard the Netflix sound before? Streaming is so common now, but 7 short years ago.
I'm sorry about that. You guys should mute yourself if you're not asking me questions. Thank you. All right. So the idea is, this is, you start with the standard one, and then we're going to shift it so that the new center is 2, 3. 2, 3. That will be the new center. Now, x squared over 4 plus y squared over 9, we know all about it. That's the a square, and that's the b. So this one is actually that. That's really this one. This is my b, which is 3. And this is my A, which is 2. So my new ellipse will be exactly the same, but the center now it will be 2, 3. And with that, we can figure out everything about it. So this is my center is 2, 3. My B is 3, so I'm gonna go up 3 units and go down 3. It's not really very accurate. And my A is 2, so I'm gonna go down a little bit, 2 from here and 2 from here. So now this is my ellipse. That's really the ellipse we care about. So that's the B here, which is equal to 3. And the A is from here to here. That's my A, which is equal to 2. My foci is right there. This is the C. Now, can I find everything I want? I will ask you now the questions. Try to work with me. So question number 1 to you is the following. What are the vertices? Can anybody give me the vertices here? Anybody with me? Sarah, tell me 2, 0 and 2, 6. Let's see, anybody agree with Sarah? Anybody agree with her? Yes or no? Yes? No? Please put on the chat. These are the vertices, this point and this point. These are the vertices. So it's a 2, and then you had a 3 plus 3, that's a 6, that's a 2, and a 0. So the vertice is 2, 6, 2, 0. What are the foci? You guys figure them out. You have a minute to do that, no more, because you don't need more than that. What's the foci? We need the C. We need to find the C square. The C square is B squared minus 4 is equal to 5. So what is my foci is? So the C here, this is the square root of 5. So the foci are going to be 2 for the first component, because everything lies on this line. The second component is going to be 3 plus root 5 and 3 minus the square root of 5. Okay? So shifted ellipse, they basically behave like ellipse. We just really shifted them. The equation will not change. Basically, the only thing changed that instead of x, we're going to put x minus h and x plus h. Right? So one more example along those lines, and then we move to hyperbola. So don't look at your notes if you can avoid them. And I'm going to ask you the following. So we're going to find, I'm going to give you 5 equation of ellipse. That we know that the foci, I'm going to give you the foci are 2 minus 2, 4 minus 2. And the vertices are 1 minus 2 and 5 minus 2. Okay, and the question is find the equation of the ellipse that have those for foci and vertices. So of course, the first thing I do is I try to remember what is the equation of the ellipse. Plus. That's the equation. So to answer any of those questions, I should know the H, I should know the K, the A, and the B. So every bit of details. Very good. So let's see. What's going to be everything? So I'm going to draw a little bit the picture because I think a little bit geometrically. And the foci are 2 and minus 2. So 2 here, minus 2. And they are also at 4 minus 2. So I have to think this way. So that's 2 minus 2, and it's at 4 and minus 2. So somewhere here. These are the foci. And the vertices are 1 minus 2 and 5 minus 2. So it's again here. So the vertices are right there. And at 5 minus 2 right there. So these are what we have. So this is the A. So the center, so this is a 2, this is a 1, and this is a 4, and this is a 5. Okay, that's enough info. So so the foci is here. It means my ellipse will have to look something like that. That's my ellipse. So first of all, what's the center very quickly? Right there. What are the coordinates of the center? 3 minus 2 is halfway between. Halfway between 2 and 4, let's say 3 and minus 2. Done with the center, it means I know my H and I know my K. Now I need A and B. What is the A? So the picture tells me what is the A. The A is the distance from the center to the vertices. That's my A. So I know immediately what my A is. If this is 3, my A is 2. So it's become fairly simple. Now I need my C. Again, it's the distance from the center to the foci. So C is equal to 1. B is easy. What is B? Okay, we know that C squared is, now in this case, because the foci are on a line parallel to the x-axis, it means I know that my A is bigger than B. So C squared is going to be A squared minus B squared. So we'll have 1 equal 4 minus B squared, giving me B squared equal to 3. And now I put the whole thing together, which gives me the x minus 3h over 4 plus y minus minus k, which is over 3 equal 2. Okay, so basically, fairly simple. Just as long as you understand the picture geometrically, you can answer all those questions. So part 2 is hyperbolas. What are hyperbolas? Ellipses had a very nice geometric definition, which is also intuitive, and we used it to draw the ellipse. So remember, the ellipse represented all the points. So the ellipse had the following, geometrically was the following. You fix 2 points, F1 and F2. That's really what was our definition. And it's all the points such that the sum of the distance to those is fixed. So that was the ellipse. So we looked at all the point xy such that the sum of the distance is a fixed number. And if you guys remember, we use, this is my 2C. We took a string of length 2A and we started drawing the picture and we got the ellipse. So it has a nice, really geometric property. And it also has the foci for the ellipse have very nice reflecting property. What do I mean by that? It means the following. Suppose you have an ellipse. That's my ellipse. And the foci are right there. And that's why they play an important role. What's the reflection property of the foci? They have the following. The book explained it as well. If you put a sound wave here, something that produces sound, the sound hit the ellipse and it reflects to the other foci. If you put a sound wave at one foci, the sound will go up, hit the edges, and it reflects to the other foci. Now, have you ever guys experienced this? A lot of you have experienced that. And let me ask you a following question. Has any of you been to the Museum of Science of Industry? Yes or no? Remember the one in Chicago? Have you been to it? On the chat. No? Anybody has been to it? Yes? Okay. For those who's been to it, there is a room called the Whispering Gallery. Anybody have heard of it? Those who's been there? Okay, what happened in the whispering gallery? The whispering gallery is just like a big hall, and really big. I mean, really, really, really big hall. And on the hall, there are two stands, very big. And here there is a microphone. Somebody stand here and whisper, basically whisper. That's what the whispering gallery actually is. The person standing very far away can hear the person whispering. Somebody next to cannot hear him because he is whispering. And so what's really going on in this whispering gallery? What's going on is that the cross section here is part of an ellipse. The ceiling is part of an ellipse. And this stand is on one of the focus point, and this is the other focus point. When somebody whispers here, even though they barely whisper, the sound wave is going to hit the ceiling and it reflects to the other one. So the person who's sitting quite a bit feet apart can hear him, but the one next to him doesn't hear. So that's really, I mean, that's something that if you guys go to the Museum of Science and Industry, go to the Whispering Gallery, and that's exactly that's the mathematics that happened behind it. What you whisper here, the person next to you can't hear you, the person here can hear because of the sound. And this reflection also used in basically performing surgery, like especially kidney stones. And when you have kidney stones, one of the surgery people perform is actually, it's not an invasive surgery. They put, the person who's sick right here on one of, and they put a machine, they put the person here, and they put a machine here. And the way they do it, they send sound wave from the machine. The sound wave hit a certain mechanism, which is the top of his ellipse, and actually reflect on the stone within another person's kidney. And the stone, because of the sound wave, will actually break. So it's really used a lot, the idea of reflection, and you should be aware of it. Okay, so that's the ellipse, and that's the reflection property of an ellipse. Now, hyperbola have geometrical definition. I will write it, but it's not easy to really draw a picture using it. So I will write it, but then I will give you the equation and work with it. So hyperbola. Okay. Geometrically, what are hyperbolas? Hyperbolas are the following. Like in the ellipse, we're going to fix 2 points, F1 and F2. And the hyperbola is going to be all the point P, all the point, such that the difference between F1 and F2 is a constant number. It's plus or minus because I'm taking the difference, could be positive or negative. So it's the difference between those two, which is constant. And like ellipse, the geometry here is actually hard. That's why I'm going to write the equation of the hyperbola for you, and we're going to analyze it. So in this part for hyperbola, I actually want to work more with the equation. And the equation is really obtained by doing exactly algebraic manipulation. So we replace this by the square root minus the square root, and we simplify algebraically, and we get to the following equation that I want actually to work with. So the equation will become the following. X squared over a squared minus, crucial, y squared over b squared equal to 1. And the foci will be given by the formula a squared plus b squared. That, if I have time, I will talk about the reflection property at the end of the hour. And in this case, the foci are on the x-axis. All right, so that's the equation, but the question is, how does it look like and what's really going on? And that's really what I really want to actually work with. So this is the equation I want to analyze it. The way I'm going to analyze it is, first, I'm going to talk about the x-intercept. All right, what are the x-intercepts? And every time I say something, I'm going to try basically to elaborate it on the picture. So what are the x-intercepts? It means if this is the equation, where does it intersect the x-axis, the y-axis? X-intercept means we're going to set y equal to 0. If y is 0, it means x squared over a squared equal to 1. It means x is plus or minus a. So step number 1, this is a, this is minus a. These are the intercepts. Okay, so this is going to call it a0, and this is minus a0. Very good. Now, part 2. What are the y-intercepts? Okay, what's the y-intercept? Okay, y-intercept, it means x is 0. X is 0. But what happens if x is 0? I will have this equal to 1. Comment. I want quick comments. Can this occur? Can this occur? Watch. This term is positive. I'm telling you minus this equal to 1. This cannot happen, can't occur. What does it mean it can't occur? It means there is no y-intercept. It means the graph does not intersect the y-axis. So there is no y-intercept. Okay, so I'm gonna try to analyze this equation as much as possible so that to see what's really going on. Part 2. Okay, to be able to have a good analysis, I'm gonna basically solve for y in terms of x. And this will make analyzing it a little bit more doable. So if I solve, so I'm gonna solve, take a new piece of paper. So that's my equation. I know the x-intercept, I know the y-intercept so far. Now to keep the analysis, I'm gonna solve for y in terms of x. Okay, so to help us fully understand it. All right, so I'm gonna have y squared over b squared. So I'm gonna bring this here, which is gonna be equal x squared over a squared minus 1. So I brought y squared over b squared to this side, leaving me with that. It means y squared is b squared times this. Okay, it means y is plus or minus b, I'm assuming b positive, times the square root of that. So definitely y is not a function of x, because for every x, I'm going to have, for every value of x, I have two values of y, one up and one down. All right, so question number 1 is the domain. What do I mean by domain? Anytime I have a square root, I have an issue. The square root is going to make sense as long as this is a positive number. Otherwise, this doesn't make sense. So this will make sense when x squared over a squared minus 1 is positive. So what does this mean? It means x squared over a squared larger than 1. It means this makes sense as long as x squared larger than a squared. So again, I go back to my graph. I know we have intercept here at a0 minus a0. But this equation makes sense when x squared is larger than a squared. It means for which value of x this would make sense. For which values of x? So let's take an example. So suppose a is 2. And I tell you x squared is larger than 4. It means which values x can take. If x squared larger than 4, it means x has to be greater than 2. Or what other values x can take? So x squared bigger than 4, that's an example. So suppose I take, can x takes the value, I don't know, -3. If I plug in -3 here, I get 9 is bigger than 4. So if x squared bigger than 4, it means x is less than 2, bigger than 2, or less than -2. So the domain here, if x squared bigger than a squared, it means x is larger than a, or x has to be less than -a. What does it mean to us in terms of the graph? It means that between -a and a, there is no output. There is no value of y. If I take x in between -a and a, the term under the square is going to be negative. So this means that the graph is two parts, part here and a part there. So there is nothing, there is no output between -a and a. All right, we're almost at the end of the analysis. Now, what else do we know? The graph has symmetry with respect to the x-axis. Why there is symmetry with respect to the x-axis? Because that's plus or minus b. So here, because we have y is either two values, plus this and minus. It means for every value of x, the y could be positive the square root or minus the square root. It means we have a symmetry with respect to the x-axis. Second, we have symmetry with respect to the y-axis because the value at x and the value at -x are the same because we have x squared. So the graph have symmetry with respect to the x-axis and have symmetry with respect to the y-axis. So there's a lot of symmetry in the graph. What else can I say about the graph? Okay, when x increases, the y will increase. When x increases, the y is increased. So the graph is starting here and it's gonna increase. This piece tells me the whole story because after that, it's symmetric. After that, it's symmetric. After that, it's symmetric. So this piece is basically telling me the whole story. The last piece, which is important for hyperbolas, is the idea of an asymptote. So asymptote. Okay. What's the idea of an asymptote? For us, what is an asymptote? We've seen, and you guys have seen, two types of asymptote so far. Either the vertical or the horizontal asymptote. So let us remember what we've seen so far. And we've seen, like, if I say that this line, usually, suppose you have a function f of x, and I tell you y equal to L is an asymptote. Means what I'm telling you is when x becomes large, the output value become close to L. That's what it means. Or when x goes to -infinity, the output value becomes close to L. And we only saw vertical asymptote and horizontal asymptote. These are the asymptotes that we've seen. Today we're going to talk about asymptotes which are not vertical and horizontal, what we call slanted asymptotes. And what is the slanted asymptote? It's actually the same idea. The idea is that when x becomes close, very large, the output value become close to what? For the hyperbola, what we care about is the following. The hyperbola is going to look like this. But the question is how wide, how much is going to look. So the asymptote is, we're going to analyze them in the following way before I give you the formula. When x goes to +infinity, okay, x goes to +infinity. I'm going to take this piece here. Let me take one piece. Y equal positive the square root. Okay? When x becomes very large, the value obtained by y will become close to what? This is a b. When x is very large, very, very large, very large, x squared over a squared -1 will be almost x squared over a squared. Means the values obtained by y will be exactly the values obtained by this. Not exactly, very close when x is large. Now, if x goes to plus infinity, x being positive, so this is going to give me b times x over a, or b over ax. So when x really becomes very large, the value that y take are very close to the value those. Means if I take large x and I compute it by evaluating this expression, I get something very close to the value obtained by the simple line b over ax. So we say that the line, so it graphically means the following. When x is very large, the y value is very close to the value obtained by b over ax. It means if I sketch the line b over ax, so let's sketch the line b over ax. Let's sketch this line. This is the line I'm going to sketch. Okay, if x is 0, the lines go through the origin. If x is a, the line is b, so this is the line which is b. So if I sketch this line, what do I know? I know the following. When x is large, the value obtained by my y is very close to the values obtained by b over ax. So we're going to say that the line b over ax is the asymptote because it describes the behavior of y when x is very large. And of course, it's going to stand this way. So y equal b over ax is an asymptote, mean when x is large, the y value and the value obtained by the simple equation are very close to each other. And this will tell me how much we have to open those hyperbolas. Now, we can keep playing the same game. And if I take the negative piece, y minus that, if I take y minus b, the difference is going to be minus b over ax. So when x takes positive, large positive, this piece will actually be the same, but here we're going to have minus b over ax. So the y value will be close to this line, minus b over ax. And that's really provide us with a good analysis of how the graph looks like. So we're going a little bit to summarize this and then work with that. So the summary, you guys have definitely all those notes on your on Blackboard. So if the foci is on the x-axis, that's the equation of the hyperbola. This is how we find the foci that we talk a little bit about it in a minute. And then these are the asymptote, b over ax. And this is the asymptote, y equal minus b over ax. And the intercept are plus or minus a, and those foci are obtained by this equation. And there is no output between minus a, and there is no y-intercept. So the hyperbola will be like this. It's going to have two different branches, absolutely two different branches. Now, if I put the foci on the y-axis, basically how the equation will change, and this one I have to emphasize. The change in the equation is, it's the same kind of, but instead of having x squared over a squared as the first term, minus y squared, it's the y squared that is at first. So it's y squared over b squared minus x squared over a squared. And c squared is always the sum of those. So I don't want you to confuse ellipse with the hyperbola. Ellipse is x squared over a squared plus y squared over b squared equal to 1. That's the ellipse. And it divides like this. A bigger than b is like that. A less than b, that's what determines what kind of ellipse we have. In this case, the foci x-axis. In this case, foci y-axis. Hyperbola is different. It doesn't care whether a bigger than b or a less than b. What hyperbola care about is what you start with. So if you have x squared over a squared minus the y squared, then this is the shape of the hyperbola. So the branches are to left and right, basically. If you have y squared over b squared minus x squared over a squared, the branches are up and down, not left and right. So that's really, so we have to start with y squared over b squared. You ever forget, it's not a big deal. You look at the intercept, and the intercept will tell you what's really going on. So right here, the x-intercept, sorry, the y-intercept plus or minus b, and there is no x-intercept, because if you set y equal to 0, you get a negative equal to 1. So if you ever forget, you just look for your x and y-intercept, and then this immediately tell you the whole story. Okay, so let's do 2 problems along the line, and then shifted ellipse, as usual. So a simple problem, I mean 2 simple problems, basically. Okay, so the first problem is determine foci, vertices, asymptote. Foci, vertices, and asymptote. Okay, so let's see what they are. Of the following. So I'm going to put it in standard format. If I don't, you have to put it in the standard format. Minus y squared over 9 equal to 1. Okay, so immediately we look what we started with. It's x squared over a squared. That's really the first term. So if it's x squared over a squared, are the branches left, right, or up and down? So immediately. Is the equation of the asymptote the same for the foci on? Yes, I tried to write it in such a way that it is. Yes, it's always the one under the b over the a, regardless how you write it. Regardless how you write it, it's always the term under the y over the term under the x, b over a. Tim, doesn't answer your question. Okay, all right. So let us really figure out everything for this. So here, that's my graph. And since we start with x squared, so we know immediately the intercept are going to happen at 2 and minus 2. And there is no y-intercept. So in this case, basically, we know that this is the picture right there. But I'm not going to draw it yet, because I want to know how much I have to open the hyperbola. And the only way I know how much open is the hyperbola is when I find the asymptote. So first, let us find the vertices. The vertices here, there is no confusion about them. Those are the vertices. This is my A, which is 2. And this is my A. So the vertices are, so this point here is minus 2, 0, and 2, 0. So those are easy. The foci. Now the c squared for the hyperbola is just the sum. So that's equal to 13. So the foci are right there. So they are going to be, this is the c from the center. That's the square root of 13. That's my c. So the foci are going to be plus or minus the square root of 13 and 0. The asymptote. We have to find the a and the b. The a is 2, the b is 3. As you realize, in the hyperbola, I don't care which one is higher at all. So the asymptote will be y equals the 2 asymptote plus or minus b over a, b over ax. So we're going to have 2 asymptote, 3 over 2x, and minus 3 over 2x. Those are the asymptotes. Now, I don't draw till basically draw the asymptote, because they tell me what's x when y is large, when x is large. What is really y? So I want to know how much is open. So we just have to graph the 2 lines. So I'm going to graph the first. All right, let's graph it. That's a line, honest to goodness line. How do you graph a line? We need 2 points. First point is the origin. The second point, usually what's smart about taking the second point is for x equal to 2. So for x equal to 2, because it's going to give me the y, which is going to be the b, that's a 3. That's a point. I have a point, 2 points, I draw my asymptote. That's my first asymptote. Now my second asymptote, it's the minus that. So if, again, it goes through the origin. So now I'm drawing minus 3/2. It goes through the origin, and so minus 3/2x. Go through the origin. If x is 2, that's x is 2. This is going to give me minus 3. So it's minus 3 down here. That's my other point. And I draw my second one. Now I know how much open the hyperbola is, because when x is large, the values are close to the values obtained on the line. And now I can draw my hyperbola in a very good way. So this is my hyperbola. And I know how much open this is. Okay. Now, the same way we shifted ellipse, we shift hyperbola. It's the same idea. The only thing changed is that when the center is changing, then the equation will change automatically. So suppose I have a hyperbola, whether it's open up and down or open left and right. So suppose it is like this, it doesn't matter how it is open. So the equation, and this is the center now. So instead of 0, right there, the center is going to change. And the equation would become x minus h squared over a squared minus y minus k squared over b squared equal to 1, or of course y minus k squared over b squared minus x minus h squared over a squared equal to 1. So it's exactly the same, but instead of x, we have x minus h. All right, let's do one problem along those lines, and then we, the problems are simple. So let's take the following. Find the equation. Find equation of the hyperbola given by. No, sorry, not find the equation. Let's consider the hyperbola given by. Okay, so to answer Tim's question, I'm gonna have y here, y minus 2 squared over 4 minus x minus 3 squared over, I don't know, 16 equal to 1. Okay, and so this is my hyperbola, and the question is find the center, find the vertices, find the asymptote, and find the foci. So everything possible above. Okay, so in my mind, what is this hyperbola? This is nothing more than the following. So this is nothing more than y squared over 4 minus x squared over 16 equal to 1. It's this one shifted. It's this one, which is it's the standard one, which is shifted. That's what this hyperbola is. So my new hyperbola is going to be the following. All right. The center, so before we start finding everything, let's go through the center. The center is, because I have a minus here and I have a minus here, it's going to be 3, but because x minus 3 squared, and 2, because y minus 2 squared. So the center, that's 3, 2. 1, 2, 3, 1, 2. So this is the center. Okay, now the question, so basically it's this one here that I am shifting. That's the one I am shifting. So question number 1 is it going to be a hyperbola where the branches move left, right, or up and down? Please, I want on the chat, what do you think? Up and down or left and right? Are you with me? Is it going to be like this or like that? Okay, if you come up and down, right, because y squared comes first. Then it's going to be up and down. It's going to be like that and like this, up and down. Very good. Now, So it's going to be up and down, and that's going to be somewhere located here. So to graph it first, I want to know what the vertices are. If I take the basic one, y squared minus x squared over 16, then the b here is 2. So when I'm going to graph it, this is going to be like that. That's the standard one. And this is the b, which is equal to 2. So the shifted one is going to act the same. So I'm going to go from here. I'm going to go by 2 units. That's my b. And I'm going to go by 2 units down. Since this is a 3, 2 will be right there. That's what's going to be. So my hyperbola is actually now going to be somewhere like that. At least for now, I'm just going to give you a picture. That's how it's going to look like. So let us find every aspect of it. Everything is going to be simple. It's only the asymptote that a bit tricky, but you will be able to find it. First, the vertices. These are what we call the vertices. And finding them is easy. So if I have, this is a, so this is 3. So that's 3. What is this one? I have 2. I'm adding 2, so it's going to be a 4. And the other one is 3. I have a 2. I'm going to take away it. Sorry, I have a 3, take away a 2. It's going to be 1. So these are the vertices. Now for the foci are easy. C squared is the sum of a squared plus b squared. So this is going to be equal to 20. C is the square root of 20. So it's going to be right there, the foci. So there, and the C is from here to here. This is my C, which is the square root of 20. So the foci are going to be, I am at 3. So this is a 3 right here. It's a 2 plus the square root of 20 and 2 minus the square root of 20. Those are the foci. Now, that's okay. Now the last question is, what's the equation of the asymptote? Okay, so I'm going to let you think a little bit about it, because if you get that, I think I'm done with this piece. So what's the equation of the asymptote? So I will draw everything, try to draw everything. What do you guys think? How are we going to find the equation of the asymptote? All right. How do you think I'm going to find the asymptote? These are the asymptote. How can I find them? There are lines. Agree with me? To find equation of a line, what do we need? We need a point and a slope. Am I correct? All right. I want a point on the asymptote. Give me a point. Remember, we're taking the basic one. The way we're getting this is we're starting from the basic one and we're shifting. That's really what we're doing. So this is the basic one. That's the basic one. And we are shifting it. So when I shift, 0 is going to be shifted right there. And those going to be my asymptote. So who can give me a point on the asymptote? Please quickly, we're almost done, but I want to leave you with that. Who can give me 1 point on the asymptote? And here, the origin is on it. When I shift, a point on the asymptote will be 3, 2. Now, what is the slope of the asymptote? Now, before we shift it, the slope R, the slope of this one is, so the slope of this one is B over A. Whatever B is. In my case, B is 2. My A, B is 2. My A is 4. 1/2. When I'm shifting, the slope has to remain the same. It does not really change. So the slope is going to be 1/2. This slope here is -1/2 or -1/2. So we have two asymptotes. This one, the slope is 1/2. This one down here, slope is -1/2. So now the equation become simple. So we'll have two equations. The first one, that's a point, and that's the slope. Y minus 2 is the slope, x minus 3. The second, y minus 2 equal -1/2 x minus 3. And this would give me the asymptote of this hyperbola. Okay? All right. So with this, we finish, one part of the conic section. Tomorrow, we still have one piece, something called quadratic equations, how to manipulate them so that we can look at them as basically as hyperbolas, ellipses, or circles. Okay. Any questions before? Now, as you guys know, your exam is, I graded your exam. You have the grade and you have comments about them. And if you have any questions about my comments or any questions about basically the grading, please join me in my office hours right now and I can explain everything. Okay? And for tomorrow, did you record the lecture from Friday? Yes, I did. I forgot to put it out. I will put it out right now. Okay? Any other questions? Yeah, I'm recording everything. Question number 2. Okay, did you okay. Question number 2 is I'm gonna assign more integral for tomorrow. And for today, I assigned the by parts. Tomorrow, I'm gonna start assigning, I guess, the partial fraction decomposition because those ones are crucial and I want you to know them. And please do the homework. And I may give you pop quiz tomorrow. I don't know. I will see. Okay, so please do the homework. All right, any other questions? All right, join me in my Zoom office hours if you have any questions about your exam or whatsoever. All right, and bye-bye, guys, for now.